Before we start, can we please come on camera if that's possible for you guys? Right. So in the last sessions, we talked about EVPN L2 multicast, right? So where the source and the receiver are in the same VLAN. And now in today's session, we would be talking about source and receiver being in different VLANs and how are we going to achieve that communication with help of EVPN VXLAN, right? So any doubts from the last session? Or do you guys remember about all the things that we discussed, SPMS, ASMEDs, all the exchanges that happened, right? Because if you are not so confident with that, EVPN, this L3 would be more confusing for you. So just wanted to give you a heads up that, it's expected for us to know about SPMS and SMEDs and how those were used for EVPN L2 multicast, right? So with that, let's get started. So are you guys able to see my screen?
Yes, Sudhamsh.
Good. Okay, thanks. Right. So in this session, we'll be talking about only EVPN OSM standalone, and MLAG multi-homing will come in the next upcoming sessions, right? And what we are not covering is that EVPN L2 multicast, bull traffic, bull multicast forwarding, and EVPN multicast here, which were discussed in the previous sessions already, right? So let me go back to this diagram, right? So this is a normal EVPN VXLAN setup where we are trying to achieve the communication, like let's say ping for that matter, between host 1 and host 2. And the criteria here is that we just have SVI 10 on leaf 1 and SVI 30 on leaf 3, right? And we do not have SVI 30 on leaf 1 and we do not have SVI 10 on leaf 3, right? So with this condition, how are we going to achieve the communication between host 1 and host 2? It's a EVPN VXLAN setup. I think someone can start it.
This is just regular unicast.
Yeah, regular unicast. So host 1 is 10.0.0.1 and host 2 is 30.0.0.1. And the gateway for host 1 is 10.0.0.254 and for host 2 it is 30.0.0.254.
Sorry, what's the question?
So like how can host 1 reach host 2 in this setup?
I mean, packet walkthrough, basically.
Okay. Yes. Yeah.
Like first it will say it is remote, like different subnet, remote host is in different subnet. So try to reach the gateway.
Right. Got it. So now the ping packet is at the gateway, which is on leaf 1. So what would happen now? Because we do not have SVI 30 here. So the routing as of now cannot happen on leaf 1.
This is EVPN, right? Like VRF Blue VNI 50. Okay.
So as of now, I haven't configured this yet. Let me know if you want me to put that in the same VRF or something like that.
Yeah, we would need a transit because there is no common like common point where both the VLANs exist.
Correct. Agreed.
So we cannot bridge also or routing on
Right.
either VTEPs.
Correct. So if that is the case of a normal L3 setup, right, we might need some transport VLAN. But in VXLAN, we would be putting them in the same VRF so that we can exchange some kind of a routes and we can achieve the routing, right? So maybe what I'll do is maybe I'll put SVI 10 in VRF blue. Okay. And I'll also put SVI 30 also in VRF blue. Okay. Let's say now we have this configuration VRF to VNA mapping. And so how are things going to work now? So on leaf 1, we have SVA part of VRF blue, and on leaf 3 we have SVA 30 part of VRF blue.
So we would generate like type 5. So each meetup will generate a type 5 for the respective subnets.
Right. And just because if this is a host, right, that's connected, we'll also generate a type 2 MAC IPs, right?
Yeah,
It's more
yeah.
specific than the type 5. So like Roshan mentioned, we'll be receiving both type 5s and type 2 MAC IPs for this host, which is both binding of MAC and IP, right? So now on leaf 1, it performs a route lookup. Show IP route VRF blue, right? So how does it look like? So the route would be something like 30.0.0.1/32, right? And it's present behind VTEP 3.3.3, right? And that would be leaf 3's MAC address. And there would be one more important field, which is important for a discussion. So what would that be?
The VNI?
Correct. So what would be the VNI here?
It would be the L3 VNI, which is
Right.
the PRF plea.
Correct. So this would be the route something that would be present on the leaf one, right? So to reach 30.0.0.1, we have to encapsulate with this VNI and send it towards this leaf, right? So that is where we are not using the VNI of SVA 30 or VLAN 10 here. So we are just using the VNI of the VRF that is common across both the leaves there, right? So now it would be encapsulating the packet and the packet would be received towards leaf 3. Right. So now based upon the VNI lookup, right, it would be handing it off to that VRF by seeing the VNI 50 because that's mapped to VRF blue. So now in the VRF blue, we'll have a connected route and that would be sent towards the host. This was pretty much similar to what Roshan discussed in the Tech Talk few weeks back, right? In a couple of weeks back. So now the host 2 will receive the ICMP echo request, right? And now host 2 will generate a echo reply. And in a similar way, leaf 3 would receive that packet because it's the gateway, right? And how does the route look like on leaf 3? Show IP route VRF blue for 10.0.0.1.
So it will point to again leaf 1, and the VNI will be L3 VNI, which is 50.
Correct. So that would be leaf 1 MAC
Yeah.
and VNI would be 50, right? And now the packet will encapsulated and leaf 1 would get that. And now leaf 1, after getting that packet, it would again do the VNI inspection and it would hand it off to the corresponding VRF. And then that would be routed in the respective VLAN once it is handed off to the VRF. And that is how host 1 receives the echo replies there, right? So the idea here is that in EVP and VXLAN to achieve L3, right? When I meant L3, it need not be necessary that SVI 30 and SVI 10 are present on all the VTEPs, right? So even though that's not the case, with the help of this VNI or the dynamic VLAN, I would say, we are achieving the communication between host 1 and host 2, the unicast flows, right? So we'll be using a similar logic even in EVP and OSM, which is L3 multicast, and we'll see how things work there. So any doubts until now? So the whole idea here is that we'll be using this VNI 50 to achieve the communication between host 1 and host 2 in unicast flows. And now let's see how we will be using. We'll not be using VNI 50 exactly, but we will definitely make use of that a dynamic VNI there. Sorry, dynamic VLAN, which is mapped to that VNI. Any doubts until here? All right. There are no doubts. I think let's proceed further. So just to recap, right, this was like the basic HCR where we did not have a snooping and we were just flooding it to all the VTEPs. And then we used VXLAN multicast where it was snooping aware, but we used to use a lot of things like route unicast route injections into underlay, and somehow we used to achieve things. But then we came up with EVPN OSM where it is like snooping aware, right? And in this case, there is no RP needed. This is the main thing here, because in the normal L3 multicast, we require an RP to know where the sender and receivers are, right? So that's not the case here. So we do not need an RP here. We will use the EVPN routes to determine where the potential receivers are, and to see which are the other VTEPs that are doing EVPN multicast. Right. Any doubts until here? Right. So looking at the basic technologies that we would be using during this session would be OSM, which is nothing but optimized inter-subnet multicast, which is nothing but the fancy way of saying doing L3 in EVPN VXLAN, right? And this is SSM, which is nothing but source specific multicast, where we know the source and we try to join the source directly. And there is no need of RP here, right? And LHR is the last hop router, which is the nearest the gateway of the receiver, and first hop router is nothing but the gateway of the source, right? And this is the important part, SBD VLAN or the dynamic VLAN. So you would see us you're using these two terms interchangeably, dynamic VLAN or SBD VLAN. Both are nothing but the VLAN that the dynamic VLAN that it gets created when we create VRF to VNA mapping. So it is nothing but SBD VLAN or the dynamic VLAN. And we all know that the underlay G is used for the underlay multicast groups to encapsulate the feed. The overlay G is the actual data plane multicast traffic the end receivers are interested in. Right. Right. So let's talk about the design part. So feel free to stop me if there are any doubts. Okay. So we are configuring the underlay group here, right? So to configure the underlay multicast group, during the EVPN L2 multicast session, we just saw about this line where we configure multicast group per VLAN. But while after introducing L3 and introducing VRFs, we can also configure multicast groups per VRF, right? And we also have a new edition where we can create one-to-one mapping as well. But for this session, we'll be talking about these two types, which is per VRF and per VLAN, right? So the question here is that, like, let's say if VLAN 20 is part of VRF blue, so which one would be chosen for that VLAN 20? Would that be 227.111 or 225.111?
So I think when you say chosen, you mean like with which IP it'll encapsulate with what?
Correct. Yeah. So like let's say now VLAN 20 is part of VRF blue, right? So now any feed is coming on this device locally and it has to encapsulate and it send it over VXLAN. So which IP would that choose? Which underlay group? Would that be 225.111 or 227.111? Any guess? Maybe a wild guess should be good.
From my perspective, I think the VRF one, because if you see the normal unicast thing also, first you use the L3 VNI and then the L2, right? So
Okay. Okay. But that's what there is a slight difference in the unicast way of doing things and the multicast way of doing things. So here we will be preferring the per VLAN, which is like a more specific one. So like let's say in VRF blue, there would be multiple VLANs part of that VRF blue, right? So out of which we are specifically mentioning that VLAN 20 to use this group. So if we have both per VRF and per VLAN, the VLAN is part of that VRF blue, it would be preferring the underlay group which is present per VLAN. Okay. Any doubts here?
Makes sense. If we logically think also, if there are a lot of VLANs, we
Right.
don't want the feed to be going to multiple VLANs, right? Yeah,
Correct. So that is
get
why
it.
there is something written here, which is like to avoid traffic polarization and stuff. We will talk about this in the later stages, right? Or else it might be a bit confusing to visualize things, right? But yeah, once we have this kind of a configuration, it is used to avoid traffic polarization as well. And the when we talk about how do we create the underlay group and underlay source, right? So this is how we, under interface VX1, we give the group address per VLAN and per VRF. And the source IP of that group would be the VXLAN source interface loopback one that we usually use for VXLAN. And there are few things here written for MLAG. We will cover them once we discuss MLAG. And this is the important part of today's discussion, where should we do PIM or not? Let's not talk about multi-homing and MLAG. Let's stick to standalone for now. So in normal L3 multicast, right, what we usually do is under that SVI, we enable PIM by doing PIM IP for sparse mode. Right. So that was L3 multicast and there was no VXLAN there. So now VXLAN coming into picture, should we still use PIM IP for sparse mode? Or if not, why? I mean, the answer is written here, but I just wanted to brainstorm a bit. And if we can get there. Any thoughts?
So your question is why in normal multicast we have SPIM enabled on the SBI?
No. So in normal L3 multicast, right, we have PIM enabled on the FHRs and LHRs, right?
Ah, correct. Yes.
So right now we are on the LHR or FHR. And should we enable PIM IP for sparse mode or shouldn't we be doing that?
Or rather, whenever we think of multicast routing, we always configure PIM on the L3 interface. And here we are trying to do a routing between two VLANs. So should we enable PIM on those VLANs?
Audience are pretty silent today. All right. So yeah, we definitely need PIM enabled on that SVA, right, to enable the routing. But the problem with enabling PIM directly on a SVI, which is extended over VXLAN, is that as of now, we don't have any hardware rules present to prevent PIM hellos going across VXLAN. So the moment we configure PIM IP for sparse mode on that SVI, so the packets, the PIM hellos, are sent across VXLAN. And the usual DR election happens and stuff like that, right? So let's say if we have 100 VTEPs, only one would be the DR. And that would break the traffic flows. So the idea here is that we need to make every logical VTEP as an LHR.
LHRDR.
LHRDR, yes. That means we should somehow stop sending the PIM hellos over VXLAN in such a way that we are completely avoiding the PIM DR election and stuff.
Basically, we don't want to create a PIM neighborship in this VLAN between VTEPs. Because if you form a PIM neighborship between VTEPs in this VLAN, there will be a DR and there will be non-DR. So you can't have multiple DRs, right? Only one of them will become the DR. So whoever becomes the DR, they will not join the they will not join the multicast tree. They will not form the multicast route and all, because that's the general behavior of non-DR. So we want to ensure only one VTEP. Sorry, we want to ensure all VTEPs are able to create multicast trees and able to able to join the multicast tree. So all the VTEPs should be a DR. So for that reason, we don't want to send PIM hellos across VXLAN from VLAN 10 or any VLAN that is extended in VXLAN. Is that clear? There are no hardware rules to stop sending those PIM hellos into VXLAN. Is that clear with everyone?
Right. Thank you, Ankit. So the idea here is that enable the multicast routing and all stuff that we do with PIM-IPv4 sparse mode, but just prevent the PIM hellos going across VXLAN. So to achieve that, we came up with this command, which is IPIGMP. So it does all the things which PIM-IPv4 sparse mode does, like acting as a querier, sending out queries, and enabling multicast routing, except generating PIM hellos. Right. So that this is the command IPIGMP, and we give it under all the SVIs which are participating in OSM. Right. And so we also see that in lot of VXLAN setups, right? We do not specifically use physical letters on the SVI. We use IP address virtual mostly, the floating IP. So in that case, we would also need another command, PIM IPv4 local interface loopback 100, because this would be the same IP on all the VTEPs, right? So that's why we need to use the local interface loopback 100, and this loopback 100 should also be part of this VRF that we'll be using. So once we do have this configuration present, if you do show IPPIM interface VRF blue, you will not see any output in that. That would be a blank output, right? Because we are not sending PIM hellos and we won't be seeing any neighbors there. So we are doing that because presently we do not have any hardware rules that are programmed on the device to prevent that. So I think now the developers are working around those lines, where with PIM for sparse mode, we are trying to include some hardware rules which would prevent sending across the VXLAN. But for now, we do not have them, and we have to use IPIGMP for standalone. And things change a bit for MLAG, but we will discuss them once we discuss that. So any doubts on this slide? So for standalone, we need to have IPIGMP to enable multicast routing. And we need to use PIM-IP for local interface if you are using IP address virtual. All right. And regarding using SFP mode or kernel mode, I think we discussed this quite extensively in the last session, and that we require SFP mode. And I think everybody agrees on that fact that we need to use SFP here, because just the kernel mode doesn't understand VXLAN encapsulated multicast feed. So again, this is VRF agnostic. So we go under outer multicast IPv4 and we give software forwarding SFP. And reload is necessary for this to take effect. And how do we check? We just use this command show agent best manager ping. Right. And the next important thing is about equipping a VRF for OSM. So in L2 multicast, we used to do redistribute IGMP under that MAC VRF, right? So to generate the SMEDs, to relay the interest and everything. So here we need not do it per VLAN as such, right? And we have to enable that functionality under the VRF. And how do we do that? By giving EVPN multicast under that specific VRF. Any doubts until now? If it's clear, then we'll see how route types would be changed with
Just one question. So we would need this command along with the redistribute IGMP in the VLAN, is it?
only in specific scenarios, but in general, it's not required. We'll see in which kind of scenarios we require that.
Okay, okay.
To just do pure L3 or multicast routing, we do not need that.
Okay, so
We have
this
that.
EVPN multicast is enough.
Yes, for
Oh,
L3 to be achieved.
okay, got it. Mhm.
If we are using L2 along with L3, that is where we might need that. But if you're just trying to achieve a pure OSM without L2, we do not need that.
Got it. Okay.
Yeah. All right. Let's move to changes that happens in the multicast routes once we enable OSM. Right. So basically for OSM, the configuration that we saw are the only ones which are required, apart from the usual EVPN VXN configuration that is present already. Right. So let's talk about the changes in the IMET, right? So if it is a normal EVPN VXLAN setup, we just generate one IMET per VLAN. So let's take VTEP 1 here, where I have VLAN 10 and VLAN 20, and I also configured VRF blue. And this SWA VLAN 10 and VLAN 20 are part of this VRF blue, right? So in this case, if you look at the routes that it is generating, one is per VNI. You will see this as VNI 10, which is nothing but per VLAN for VLAN 10, right? And the other one is for VLAN 20. And the other route, the third one that we see is with RD1 colon 1500, which is the RD of the VRF, right? And you see the VNI, this is the VNI that is given for the VRF, right? So we need this to advertise the OSM capabilities to the neighbors, right? So initially when there was just L2, right, and we were doing redistributed IGMP, we were seeing IGMP host proxy in the IMETs that are generated per VLAN. But here the L2 IMETs are plain, but the IMET that is generated per VRF, we have all the capabilities listed here: IGMP proxy, OSM supported, and SPD. Right.
Yeah, and just to clarify, the first two IMET that you see for the VLANs, that is just the regular IMET that we generate in EVPN unicast to announce, what is a VTEP IP. So you see the tunnel ID 100.0.0.1, that is a VTEP IP. So that is just a regular EVPN behavior, right? When you use EVPN, even in unicast, we generate IMET route for each VLANs. That's what you see as the first two. But the third one is for related to OISM, where we have the multicast flags, which says IGMP proxy, OISM supported, and the SBD VLANs.
Sorry, just a query. So in this case, the redistributed IGMP is there or not?
It is up there.
It's not there. Okay.
Even multicast that's present.
Okay. Got it.
And even with this command alone, we are announcing the IGMP proxy functionality. So that means we are able to do the send the interests from the local receivers.
SMET route.
SMET routes. Right. So now let's talk about the next change, that would be type 10 routes. So in this case, let's say we are on VTEP 1 currently, and on VTEP 1, we have this configuration. So we have VLAN 10 and 20 present. Okay. And we also have VRF blue. VRF blue is mapped to VNI 1500. Now, like we discussed, right now we have per VRF multicast group, which is 227.111. And for VLAN 20 alone, we have which is 225.111. Right. So is that clear? The existing configuration on VTEP 1. And with this configuration, let's see what kind of SPMS routes are generated on VTEP 1. Okay. The first one would be for VLAN 10, right? So MPLS label is 10 here. And if we look at the route targets, we have two route targets here. Unlike the L2 multicast, where we just had one single L2 RT, here we have route targets of both L2 and L3. So this is one change that happens in SPMSI once we are going from L2 to L3 multicast. So we will include two route targets. One would be L2 route target, that is 10:10. The other one would be L3 route target, which is of that birth. And if you look at the tunnel ID, that would be 100,001, and the group would be 227,111, which is configured per birth, right? So now we also have VLAN 20 part of that birth, right? So let's see how that route looks like. So again, we have MPLS label as 20, and again we have two route targets. One would be L2 and the other is L3 here, right? So the route target 2020 is that of L2 and route target 1500 is that of L3. And now if you look at the tunnel ID, it is not 227,111. It is 100,001, the source, and the group is 225,111. It is using this because we have more specific group configured per that VLAN 20, right? And this third new SPMSA route, and this was not present in normal L2 multicast. So this is a new addition which is generated per perf. So the MPLS label is 1500, which is nothing but of that perf, and the route target is just L3 route target. And the tunnel ID would be 100,001 and 227,111, which is configured per perf. So just to see how many SPMS routes are created, right? So that would be one per VLAN and one per perf. So in this case, we have two VLANs present and one perf. So total in this case, we are generating three SPMS routes, right? So similarly, if we look at VTEP 5, we have VLAN 10 present and VLAN 30 present. And we just have the group configuration per VRF. We do not have any per VLAN specific underlay group configured. And now if we look at the routes that it generates, so we have L2 RT and L3 RT for VLAN 10 route, and the tunnel ID here is that 150,005 and 227,111, which we gave for multicast group. And similarly, let's look at for VLAN 30. So the MPLS label is 30 here. And again, we have L2 RT and L3 RT present in that. And the tunnel ID is again 227,111. And the third route that it generated is per VRF, where we see the MPLS label of that VRF. And the route target is just the L3 route target. And the tunnel ID is again 227,111. Is that clear, guys? Like the change that we saw from L2 to L3 in the SPMS size.
Yeah, and on the right side, on VTEP 5, the SPMSA that is generated for per VLAN, we see 227,111, which is the group for VRF. That is because there is no group specified per VLAN. Okay, but if you, let's say, as you see in the left side, you have specified a group which is 225,111 for VLAN 20. Now the SPMSA that is generated for VLAN 20, you will see the group that is using 225,111. So if you specify the group for the VLAN, that is what's going to be used in the per VLAN SPMSA. Okay, so that is a difference we have to understand. Now there is a reason why we are including both the route target in this per VLAN SPMSA, where you have route target 2020 and also route target 1500, which is the VRF route target. So there is a reason why it, and we'll discuss that why it is added here.
Yeah, thank you. Okay. So on VTEP 1, let's say if there is any feed that is coming in VLAN 20, it will encapsulate with 225,111. And on if it's coming in VLAN 10, it would be using 227,111. Right. And there is one important output that I would like to discuss here, which is very much important for this OSM to work. So that is show VXLAN VNI output. So this part is just created as soon as we configure VXLAN to VLAN mappings, right? Basically, these are the static ones, right? And let's say if there are any other interfaces, part of that VLAN 10, that would be seen here as well. Like let's say any local interfaces. And let's talk about the dynamic part here, right? So we see this last line, right? A VNI 1500, which is mapped to 4094 and part of VRF blue and source is EVPN. So do you guys remember when would this mapping be created? This would be created in EVPN normal unicast flow as well, VXLAN unicast flows. So the moment we give this VRF to VNI mapping, right? So that would create a dynamic VLAN to VNI mapping here. The last line that you see, 1500 is mapped to 4094. So the two entries that we see here are an addition from EVPN multicast. So let's see how these two entries are created. So these two entries are not created due to any local configuration. Rather, these two routes are created from the routes that are received from the remote peers. Okay, so
Sorry if I missed this, but how did this VLAN 4094 came here?
so this is the dynamic VLAN. We have a dynamic VLAN.
Okay.
On
Got
like
it. I was just seeing that where is this configuration. So it's a dynamic one.
yeah, it's a
Got it.
dynamic. It's good.
Yeah, thank you.
So we see these two entries, right? Let's see how these two entries are created, right? So this is saying that VNI 10 is mapped to VLAN 4094. And how is that achieved? Let's look at the route which is sent by VTEP1, right? And we see this route with MPLS label as 10 and route targets. We see the L3 route target here. So it would be importing this SPMSA route into that VRF, but should it immediately create this entry just because we have an L3 route target? So let me rephrase my question. So we have this mapping here. VNI 10 is mapped to VLAN 4094, right? But how is this created? So one would be one route that it utilizes is the SPMSA route. So it sees the VNI 10 and it sees the route target, L3 route target 1500, right? So at this point, it will try to install this into this table, but it will also make use of the L3 IMET that we sent, right? Which is where we have the OSM functionalities. So it would see the route target that it has, and it also compares with the route target in the IMET that it generated. So when VTEP5 receives this SPMSI and the IMET that we saw previously, which has the functionalities announced, OSM and SBD, looking at those two routes, it will create this mapping. Right. Similarly for 20 also. So we received this SPMSA from VTEP1, right, which has L3 route targets. And we also have received one IMET with this route target and with this VNI, which has the OSM functionalities. So that is why we are creating this entry as well. And that is why we see that source is EVPN multicast. Like let's say in the future, let's say we are creating one more VLAN 30 here or VLAN 50 for that matter on VTEP1, and it is part of that VRF blue. Then we will also see one more entry here, VNI 50, and it's mapped to 4094 and part of VRF blue. So these two lines are not coming from the local configuration, rather from the routes that it's received from the remote VTEPs. And we will see where this output is used. All right. So two takeaways from this slide is that we generate how the route types are generated. So if in the per VLAN SPMS that we generate, we will include both L2 and L3 route targets, and we generate one new SPMSI, which is per VRF, which has just the L3 route target. And the second one is how this VXLAN to VNI mapping is created dynamically.
Yeah. And I think it's important, like, why are we talking about this mapping in the first place? Why is this mapping important? Can anyone think? Why are we mapping a VNI to a VLAN? And we do that even in L2, right? We basically we always map a VNI to a VLAN. So that, why do we do that? Why is that important? Okay, so maybe, I mean, we'll cover this in the future scenarios, but basically we need to uh, assign the traffic. Whenever you receive a traffic in VXLAN, it comes with a VNI, right? So that VNI has to have a meaning, right? It has to map to some VLAN. So that mapping helps in deciding which VLAN that traffic should go. Okay, and we'll see in the next scenarios how this mapping is more, uh, like how it makes more sense. Yeah. Sorry, Sudhanshu, you can continue.
No, thank you for adding that. So now we see that we have both L2 and L3 route targets in the SPMSA, right? So let's discuss why are we including both L2 and L3 route targets in per VLAN SPMSA? Any thoughts? Why do we need that? So in the last slide, we saw that in the SPMSA routes that we are generating, we are including both L2 and L3 route targets in that. So why are we doing that?
So the L3 route target is to let them know which VTEP it should be imported, and the L2 is to know which VLAN it should be imported.
So if it is doing OSM, right, just importing into that VRF should be enough.
Hey,
Yeah.
sorry, I think I lost you. I don't know if it was just me.
Oh, is it? Can
Yeah,
you
I
please?
think even I lost you.
Okay,
I heard it okay. I don't know.
got it.
Maybe you can just start again. Yeah.
Yeah, sure. So we are just discussing why are we including both L2 and L3 route targets in the per VLAN SPMSI that we generate. One hint would be here is to think in terms of the L2 VTEPs in the network. Right. So what I mean by L2 is that the VTEPs which do not understand the L3 route target. So is the question clear, guys? Or should I explain it a bit more?
Your question, I think we understand is why both route targets are needed.
Right.
Why both advertise L2 and L3?
Yeah, why can't we just do with L3 route target alone? All right, maybe let's discuss this scenario and let's see if you guys are able to come up with the answer for that. So we have one receiver here in VLAN 20 behind VTEP 1. And this is just a L2 VTEP for that VLAN 20. That means we do not have SVI 20 present here. Okay. And we have a source here on VTEP 5, and which is also publishing the feed in VLAN 20. And here we have that SVI 20 part of this VRF prod, for example. So in this case, now let's say sender is coming online behind VTEP 1, right? It should join the available underlay groups, right?
Sorry, who is the sender? Is it the one on the right side or on the left
Yeah,
side?
this is the source.
Okay, that is the sender. Okay.
Yeah. Now this receiver is coming online behind VTEP 1 in VLAN 20, which is just an L2, right? So now the moment it comes online, it would generate an SMET and it would try to join the existing underlay groups, which are advertised by SPMSA routes. So now let's say this VTEP 5, if it just advertise the SPMSI with L3 route targets, that SPMSI is not imported into that MAC-VRF. So there is no way that VTEP 1 can join the underlay of VTEP 5. I mean, take some time to visualize things and let me know if there are any doubts here.
So are we saying it needs L2 RT because there is no MAC VRF or like that VRF prod is not there?
Correct.
So
Yeah,
it will not be able to read the L3 VNI.
correct. So it will not be able to understand just with L3 RT because here the VLAN 20 is we do not have SVI 20. So the only thing it can receive the feed is from that VLAN, basically just the L2 feed that it can receive.
Okay.
So
Yeah.
in this case, let's say if we talk about VLAN 10, for example, let's say the VTEP one, right? It receives this route target. Let's say if it is just receiving with route target 1500 for this MPLS label 10, there is no way that the receiver in VLAN 10 can receive the feed from VTEP 5 if we just send it with this L3 route target. Considering VLAN 10 is just an L2 on VTEP 1.
So end of the day, we need to import the route, right? And you don't have the L3 route target on VTEP 1 because there is no VRF. Or so in that case, how do we even import? Right, if you have a complete L2 VTEP, then it can only import based on the L2 route target. Right, so that is the reason when VTEP 5 will generate the estimate for VLAN 10,
Sorry, SPM.
SPMSI when it generates the SPMSI for VLAN 10, it will have both L2 and L3 route target. So that any L2 VTEP can also import those route. Yeah, and you can think like in this topology, there are other VTEPs which are L3. Maybe only this VTEP 1 is L2, which have a receiver connected. So all other VTEPs which are L3, they don't need the L2 route target in the SPMSI, right? Only this VTEP 1 needs it. Nitish, is that clear?
Yes, yeah, I got it. Thank you. That helps.
Cool. Okay. Thanks.
All right. So let's move to next change that we see. So that would be in the SMET route. So what does SMET usually say or advertise then to the neighbors? Like there is one receiver behind me. So kindly send one and add a PIM tunnel in your snooping table and send one copy towards me. So that's what essentially SMET does, right? And when we have just EVPN multicast under that VRF in router BGP, this change happens. So initially, when we just used to have redistributed IGMP, right, we used to generate the SMET with L2 RT. But now we do not have redistributed IGMP and we just use EVPN multicast. So with that, the SMET that it generates is only with L3 RT. So let's say now a host is coming online in VLAN 10. and it is looking for feed from 239.10.10. Sorry, it's 239.111, right? So the estimate is generated for 239.111, and the route target that we see is just of that VRF, not per VLAN L2RT here anymore, right? So now if once VTEP 5 receives this estimate, before estimate, right, we see show IPIGP snooping groups detail as something like this, where we do not have any entry for 239.111. Once we receive the estimate, we see a snooping entry created for group 239.111, and the member is PIM tunnel, but the VLAN here is 4094, which is mapped to dynamic VLAN, not the VLAN 10. It is mapped to VLAN 4094. So this is another change that happens with L3 multicast. We don't send route targets with L2 RT, and we send it with L3 RT. Is that clear? All right. So similarly, how we did for SPMS, right? SPMS are generating the routes. The SPMS routes are generated with both L2 and L3 RTs, right? So similarly, we can also make SMET to generate both with L2 and L3 RTs to cater few scenarios, right? So to do that, we have to give redistribute IGMP under that VLAN 10. So if we do that, even the estimates would be going out with L2 and L3 route targets. Again, if it is just a pure L3 OSM that we're trying to do, we do not need L2 route target. And we require L2 route target only in few specific scenarios. And in that scenarios, we will use redistribute IGMP in the receiver VLAN 10. So let's see how the snooping table looks like once we include both L2 and L3 route targets, right? So with the help of L3 route target, this entry is created 239.111 and is mapped to VLAN 4094. And including that, we are also creating one in VLAN 10 because we use redistribute IGMP and it is coming with this route target.
Yeah, and you can imagine on the VTEP 5, the VLAN 10 is completely L2, like there is no SVI. So in that case, for VLAN 10, um, you need the PIM tunnel against the VLAN 10, not the VRF.
Yeah, we'll discuss that scenario which Aniket is talking in the next slides. So is this point clear? Like when we can also generate estimate with both L2 and L3 RTs or just L3 RT here. If you want to generate with both L2 and L3 RTs, we need to have redistributed IGMP under that VLAN 10. Once we give that configuration, we'll also include L2 route target with the existing L3 route target. Now let's see in what kind of a scenarios we need this L2 route target, right? So now the scenario is changed a bit. So we have a receiver here, and this receiver is part of, we have a SVI 20 present here, and it is also part of VRF prod. But now, unlike the last scenario where the source is present behind an L2 VTEP, in this case, the source, which is behind VTEP file, and there is no SVA on VTEP file. So essentially, the sender is behind an L2 VTEP. Right. So let's say in this case, now the receiver is coming online, and let's say we are generating an estimate route uh, with just L3R route target, right? And when we just send it with L3 route target, VTEP 5 would create something like this. Just the PIM tunnel corresponding to dynamic VLAN 4094. But just because we do not have SVI 20 there, and which is mapped to the VRF, this entry doesn't make any sense on that VTAP because it's an L2, right? So that is why in that case, we would also need one snooping entry for VLAN 20, because here the sender is in VLAN 20. So now let's say if this guy is sending the SMET route, let's say it includes both L2 and L3 route targets. So in that case, we'll also create one similar entry, something like this for VLAN 20, right? Now it understands VLAN 20 and it sees that there is a PIM tunnel in the snooping table. So that is why it would encapsulate and send it out over VXLAN. So basically nothing but if there is just a source behind an L2 bit, it just creates a snooping entry in dynamic VLAN from the received estimate because it just has an L3 route target. And with this, the feed cannot be sent encapsulated and sent over VXLAN just because we do not have any snooping entry for that L2 VLAN yet. And to create a snooping entry for that L2 VLAN, we need to include both L2 and L3 route targets. So essentially, just to summarize, right, even in a SPMSA or in SMETs, we need to include L2 if there is any EVPN L2 multicast happening in the network. So to cater those scenarios, we will include L2 route targets. If it is pure OSM, like in all the scenarios, the senders and receivers are in different VLANs. So then we do not need L2 or RT at all. But in SPMSA, by default, we generate it with both L2 and L3 route targets. But in SMET, it is in our control. And we have to configure if we have to send both L2 and L3 route targets. Yeah, these are the changes that happens with L3 multicast. And if there are no further doubts, I think we can go into the traffic flow that would give us a much more better picture of what we discussed until now. Any doubts until now, guys?
Is everyone following, guys? Mani, Arjun, Sam, Rupa, Advait, are you all following it?
Yes.
Yeah.
Okay.
So one question, like redistributed IGMP is needed on both VTEP 1 and VTEP 5, right? Or it's just needed only on the VTEP 1?
Just on the receiver VTAP.
Okay.
Sorry, Mani. So just on the receiver VTAP.
All right.
Yeah, because that is when we would generate an estimate, right? So the estimates are generated on the receiving VTAP. So to include L2 RT in the estimate that we are generating, we would need that redistributed IGMP.
Okay.
Yeah, we understand that it's a bit of a confusing and tricky topic, but feel free to go back and again check the slides once after the session, and that should be clear. And let's talk about the, yeah,
Sorry, once we do the scenarios, I think maybe that will give much more clarity.
yes, yeah. So let's talk about the traffic flow that would clear a lot of confusions that you guys might be having. All right, so this is the topology that we will be using where we have our spines and 5 VTEPs, right? The dynamic VLAN that is being used in the scenario is 4094 on all the VTEPs. Okay, and VLAN 10 is extended on all the VTEPs from VTEP 1 to VTEP 5. And VLAN 20 is extended only from VTEP 1 to VTEP 4. and VLAN 30 only exists on VTEP5. So these are the initial variables. Let's come to a more specific flow that we will be tracing, right? So this would be a scenario that we would be looking into, where the receiver is in VLAN 10 on VTEP1. Basically, we have the receiver here, and the source is in VLAN 30 on VTEP5. Rupa, I was asking something. You were on mute. Okay, cool.
Yeah, and just to clarify, the VLAN 30 is not present on VTEP 1 and VLAN 10 is not present on VTEP 5.
No, VTEP 20, VLAN 20 is not present on VTEP5.
Okay, okay.
So
Yeah.
basically,
So,
VLAN 10 is present on all the VTEPs.
yeah.
VLAN 20 is present from VTEP 1 to VTEP 4, and VLAN 30 is only present on VTEP 4.
So maybe let's just focus on the VLANs for that is related to this
Correct.
flow. So
Yeah.
VLAN 10 is present on both VTEP 1 and VTEP 5,
Yes.
but the VLAN 30 is only present on VTEP 5.
Correct. Yeah.
I want
That would
everyone to keep that in mind.
right. So we have this configuration on VTEP 1. Again, so the assumption here is that we already have the existing EVPN VXN configuration that is required for the unicast flows, right? So with that assumption, we are going into this scenarios, right? So on VTEP 1, we have this configuration. We have VLAN 10 to VNI 10 mapping, VLAN 20 to VNI 20, and this VLAN 10 and VLAN 20 are part of this VRF blue. Okay, and the underlay group per VRF is 227.111. And we do have for VLAN 20, but we can ignore this for now because we are not using it anyway. All right. And on VTEP 5, we have VLAN 10 and VLAN 30 configured, and those two are part of this VRF blue, and its VNI is 1500. And the multicast group that we are using for VRF is 22111. And there is no per VLAN specific underlay groups that we have configured. All right. So now let's say a T is equals to 1, right? LHR is getting an IGMP report for 239.111 because that is the actual group in which the host is interested in. All right. So now the VTEP 1 receives that IGMP report, and that would create a snooping entry. So if you run the output show IP IGMP snooping groups detail, you will see in VLAN 10 there is an intercept received in 239.111, and the memory interface are 85/4. There is also this output groups local detail that is just an elaborative output of the same thing. So we can skip this for our discussion for now, and if we can discuss this at the end of the session if required. But essentially, these both outputs are same. The second one being a bit more detailed output. That's it. Okay, and it also creates a star G entry. So now VLAN 10 is part of VRF blue. So if you run show IP mroute VRF blue, you will see a star G created, right? In which OIL is VLAN 10 and the incoming interface is SBD VLAN or the dynamic VLAN that it is created. So this is very important to understand and remember, guys. So the OIL would be VLAN 10 and the incoming interface would be VLAN 4094 if we are looking into the output, the mroute output in the VRF blue. And this is created for the actual group in which the receivers are present, 239.111. All right. And it would also generate estimate routes, right? And we see that it's interested in 239.111. And the route target it is using is just 1500 colon 1500. Okay. And with these two things, it will also join the underlay, right? So if you look at the M route in the default VRF, not the VRF blue, you see there is, if you do show IP M route, it has joined these many groups. Let's decode every group that it has joined, right? If you see 225.111, this is basically for VLAN 20 that it has received from all other VTEPs, because here the feed can be in any VLAN, right? It can be in VLAN 20, VLAN 30, or anything. So it will try to join all the SPMSIs that are received with that L3 route target, right? So for us, let's look at this group for now, which is 227.111, which is configured per VRF. 227.111, which is configured per VRF on all the VTEPs, VTEP 1 to VTEP 5, right? So it is joining the underlay group, which is sent by VTEP 2, which is 100.0.0.2, and VTEP 5, which is 150.0.0.5, and VTEP 3, 200.0.0.3, and VTEP 4, 200.0.0.4. This you can ignore this 100.0.0.1 because that would be created once it has received the join from the other VTEPs. So the main important ones are these four ones. Basically, it is joining all the underlays that are advertised by the remote VTEPs. So this group 227.111 is being advertised by VTEP 2, VTEP 5, VTEP 3, and VTEP 4. So it has joined all the groups. So it has also joined 225.111, which is configured for VLAN 20. So you never know where the source is present, right? So we'll join all the possible groups. So that is why we have also joined 225.111, which are advertised from VTEP 2, 100.0.0.2, VTEP 3, which is 200.0.0.3, and VTEP 4. If you remember, 225.111 was not advertised by the VTEP 5. So that is why we are not joining the 150.0.0.5, because this group is not advertised by them. So this is where the underlay joining happens. If you look at one example SD, right, 227.111 for 150.0.0.5. Here, the incoming interface is Ethernet 2/1, which is interface towards the spine. Is that clear, guys? The IF is towards the spines here. And now, if you see the OIL, this is the SBD VLAN that you see again here. So whenever any encapsulated feed comes onto this group, or the feed that is coming with the group as 227.111, we have to send it to SBD VLAN. That's what this SG says. And if you see the SGs for all these groups, that would look something similar to this only, where the OIL would be 4094. So just to,
Can we say like this dynamic VLAN is a kind of bridge between the overlay and the underlay?
yes, so basically whenever an encapsulated feed comes in, right, we have to hand it off to that VRF. So handing it off to that specific VRF is done by the dynamic VLAN or the SPD VLAN. So that is why you see OL as 4094 in the M routes that are present in the default VRF.
So that's outgoing here, and it's incoming here.
Correct, in the non-default.
Yep, exactly. Rupa.
Good, thank you.
So when you receive the traffic, the while is 4094 SBD, and then the traffic goes into the VRF, respective VRF blue, where you see the same SBD as the IF here, which is how the traffic has entered the VRF. And here you see the wireless VLAN 10. Mhm. That's correct. And I just want to highlight one more thing, right? So here you see, so both VTEP 2 or like 100.0.0.2, that is VTEP 2, right?
Yes.
So VTEP 1 is joining the underlay tree for the group 225.111 and 227.111 that is coming from VTEP 2. Now you might be thinking, if that is the case, you have, if you're receiving the SPMSA with 227.111, why do you need to join 225.1? What is the need to join both? Right? So, I mean, we discussed that if your source is connected in the VLAN 10, in the local VLAN, it'll always use the VLAN group, like whatever is the multicast group that you have defined for the VLAN, that's what it should be using. So here, ideally, if the sender sends the traffic, the VTEP 5 or whatever is the VTEP, it will always encapsulate with 225.111. Then why are we joining 227.111? So the reason is that your source, if the source is connected directly to the sender VTEP, let's say the sender VTEP is VTEP 5. So if let's say the source is directly connected on VTEP 5, and from that VLAN you have given the multicast group 225.111 for VLAN 30, right? Then obviously it will encapsulate with the outer DIPS 225.111, which makes sense. But there are cases where the source is not directly connected to VTEP 5. It is connected to outside PIM, another PIM domain. Like it is connected to L3 link and going to another PIM domain. So if the traffic is coming from another PIM domain, then it will be encapsulated with 227.111, the L3 group. So here VTEP1 doesn't know where how the source is connected. It might be connected directly on VTEP5. It might not be connected. If it is directly connected, then the traffic will be coming with 225.111. But if it is not directly connected, then it will come with 227.111. So it needs to join both the underlay groups so that, when whichever group the traffic comes, it will always able to receive it. Is that?
Basically, the idea here is that it doesn't know where the source is exactly present, and it will join all the underlay groups that are present in that verb.
Yeah.
All right. So let's see the flow again, right? So once the host is coming online, and it would generate an IGMP report for 239.111, and we would create a snooping entry in VLAN 10, and we would generate an estimate and send it across the VTEPs. And that estimate will just have L3 route target, and parallelly, it will also join the underlay groups here. And before sending out the estimate, it would also create a star G entry in the non-default VRF, which is VRF blue in this case. So report comes in, it would snoop it, and it would create a star G entry in the default verb, in the non-default verb, that is VRF blue, and it would generate an estimate and send it out, and it will also join all the existing underlay groups at t equals to 1. Okay, let's move to t equals to 2. Let's say remote VTEP receives estimate. In this case, example VTEP 5, right? And before estimate, right, if you see show IP IGMP snooping groups, there is nothing here. Once the estimate is received, you see this entry being created. For the group 239.111, we see the VLAN as 4094, and we have PIM tunnel for that. Right. So as of now, we do not have the receiver online yet on VTEP 5.
A source, right?
Sorry, the source behind VTEP 5. So if you look at the show IPM route for 227.111 and the source as 150.0.0.5, you will see that incoming interface is loopback 1, which is local, and the OIL is ET29/1, which is basically this interface, which is going towards the spine. And we wrote it as VTEP 1 because VTEP 1 was the one who initiated the join. So this is not normal underlay tree that has been built because of this S, G joins that VTEP 1 has set. And if you look at the output of show IPM route VRF blue, it is still empty because we do not have any local source. For that matter, we do not have any receiver also. So we will see some M route in VRF blue. Either we have a receiver or a source. So once the remote VTEP receives the estimate, it would create a snooping entry in VLAN 4094, and it puts a PIM tunnel across it. And because of the underlay joins that VTEP 1 has initiated, we have also completed this underlay tunnel, and this underlay tunnel is like IAF is loopback 1, and the OL is ET29/1, which is towards the spine, and which in turn would be facing towards VTAP 1. And if you look at the show IPM route in the VRF blue, that would be empty because we do not have neither source nor receiver on that VTAP yet. All right, at t equals to 3, FHR receives the source traffic. So now the feed is coming in VLAN 30. All right. So the moment you receive the feed in VLAN 30, and if you do show IPM.VRF blue, you will see a SD created. Is that clear? So this is the SD that is being created. IAF is VLAN 30. Now it sees this tunnel present, right? So any traffic which is coming in this SBD VLAN, we have to send it across VXLAN. So that is why we see that this feed is being encapsulated and sent towards the spine. And if you look at the underlay S comma G, this would be 150.0.0.5, and the group is 227.1.1. And the actual feed is 30.0.0.5 and 239.1.1.
So here, if you had configured multicast group for VLAN 30 directly, then the outer DIP would have been the multicast group for VLAN 30, not this 227.1.1.1, which is for the VRF. But because there is no multicast group defined for VLAN 30, we will use this multicast group for VRF blue. Okay, but the preference is for VLAN. Like whatever the multicast group is defined for the VLAN where the source is connected, that is the multicast group that will be used.
And one other important point that I'd like you guys to see here is that the VNI with which it's going, right? The VNI is the local VNI 30, not the SBD, the VNI per VRF. As of now, we see that even for the L3 multicast traffic, it is going out with the L2 VNI itself. We are not using the VNI of the VRF here.
Yeah, but let's say the source was not connected to VLAN 30. Let's say it was connected to L3 router or something, then the VNI would be the L3 VNI. Okay, but because the source is connected in the VLAN, which is extended, that is why you see VNI 30. So these are the differences we need to understand.
Yeah. So even both L2 and L3 case, we will just use this VNI 30 here, unless we have an external source present behind a bit.
Yeah.
Right. Okay. Now let's see how this VNI 30 is decoded on the receiving bit. Right. So now VTEP 1 is receiving the encapsulated feed, right? And if you look at the show IPM route, right? So this is the normal existing one that is already present. And now let's look at the M route in the VRF blue. So we see that S comma G is created here. The source was 30.0.0.5 and the group was 239.1.1.1. So we see the IF as VLAN 4094 and the OL as VLAN 10. But let's understand how this entry is created, right? So now let's say if VTEP 1 is receiving this packet, right, which is routed across on spine and it is coming on to VTEP 1. And if, let's say, on VTEP 1, you have this S comma G present, OL as 4094. But it is coming with VNI 30, right? But how would VTEP 1 understand VNI 30? So the VTEP 1 is receiving the feed encapsulated with VNI 30. And if you remember, on VTEP 1, we do not have VNI 30 present at all. But we are seeing that, the end receiver is getting the feed. So how is that happening? So this is where the output that we discussed initially, right? During the type 3 and type 10, the show VXLAN VNI output. So it would make use of that output to map it to the respective dynamic VLANs. So if you look at this output on VTEP 1, show VXLAN VNI, you see that VNI 30 is mapped to dynamic VLAN. So with the SPMS and IMET routes that are received from VTEP 5 initially, it has already created this mapping. So now any traffic which is coming in VNI 30 would understand that, okay, it is part of this dynamic VLAN 4094, right? And so that is why the packet is on VTEP 1. It understood the VNI. And once the packet is decapsulated, looking at the M route in the default VRF, it will hand it off to VLAN 4094. And once the packet is coming into the VRF blue, it would create a S, G. Basically, it would route from VLAN 4094 to OL VLAN 10, and it would send it towards the host. And let's say if I take a caption on host 1, right? And let's see how the packet looks. If you see the source MAC of the packet, that is the MAC of the VTEP 1, not of the host 5 anymore. Because the packet is routed on the VTEP 1. And if you look at the inner TTL, it is 63. So if you look at the inner TTL, while the packet is egressing out of VTEP 5, it is TTL 64. Whereas if you look at the TTL in the packet which host is receiving, you see the TTL is 63. So essentially the packet is routed on the receiving VTEP. And that is why we see the source MAC as that of VTEP 1 and the TTL as 63. Yep. So that's all. So with this, all the flows, the host 1 would receive the feed. So any doubts until here, or else we can just summarize whatever we saw until now. And any reason why in the S, G that is created in the VRF blue, we still see the incoming interface as VLAN 4094.
The routing is happening on VTEP 1.
Right.
And
We don't have VLAN 30.
yeah, we don't have any, correct.
Right. That is one reason. And also the other reason is that when you do show IP route to 30005 in VRF blue, right, you will have a /24s, the type 5s, which are
Type
advertised,
fair.
yeah, from VTEP 5. And that would be with VNI of 1500, right? So that is nothing but the VLAN 4094. So that is why you still see incoming interface as VLAN 4094. If at all VLAN SVA 30 was present here as well on VTEP 1, this would change slightly a bit. We can see in the next upcoming sessions where we have that scenarios there. But in this case, the IAF would be again 4094 itself. So
In that case, incoming interface would have been VLAN 30.
correct. If at all there was an SVI 30 on VTEP 1. So one key thing to note here is that the routing is not happening on the VTEP 5, on the source VTEP. Rather, the routing is happening on the receiver VTEP. And this output is very important to understand the remote VNIs with which the traffic is coming in. Right? So let's summarize things what we saw until now. So at t equal to 0, receiver comes online and sends IGMP report for 239.111. So at t equals to 1 on LHR, which is the DR itself, because we do not have any other devices there. So it populates a snooping table. It creates a star G in VLAN 10 in VRF blue, right? And it would generate a star G estimate for 239.111 because there is a receiver. And it will also join the all underlay multicast tunnels, whichever it has received from the peers with that L3 route targets, right? And at t equals to 2, all the remote VTEPs would add PIM tunnel against their SBD VLANs in the snooping table because it has received the estimates with L3 route target, right? And we'll also see that their underlay is also populated due to SSM sent by LHR, which was VTEP1 in our example, right? At t equals to 3, there is a source traffic that is received on FHR, which was VTEP5 in our example, right? The feed was coming here. It will create a S comma G with IIF is equal to source VLAN, which is VLAN 30 in this case, right? And it will also inherit any OALs if at all there is any star G present already. And since there is no star G in this case, we will just see one M route with incoming interface as source VLAN. That is comma G alone, right? And what will it do? It will route or bridge to all the local receivers. It might be possible that there are local interested receivers as well, right? On the VTEP itself. And that could be the same VLAN or different VLAN. So that is why it will route or bridge in the for the local receivers. And one encapsulated copy would be sent across VXLAN because we have a PIM tunnel present in the snooping table for that SBD VLAN, which is 4094. And as we discussed, this copy is always bridged. When we meant it is bridged, the VNI would always be the VNI of that VLAN. So that is why we are using VNI 30, right? And the TTL is not decremented. Again, the TTL would be decremented if it is a peg, which is what Ankit was discussing. But in this case, the TTL is not decremented like we saw here, right? The TTL was 64 once even the packet is going out of spine, right? Outer DIP will be the multicast group assigned explicitly to the VLAN, or if there is no configuration per VLAN, it would use the per VRF groups, right? At t equal to 4, receiving VTEP would decapsulate and that would associate with relevant VRF from the show VXLAN VNI output that we saw, and it would export. And the RPF would pass in the imported VRF because either it would be VLAN 30 if the SVA is present locally, or it would be VLAN 4094 again. And once the packet is decapsulated, the packet will be routed to the OLs, or it would be bridged to the OLs if the VNI, if the interested receivers are in VLAN 30 as well. Yep, this is the general sequence of events that happens in the L3 multicast.
Yeah, and I think it might be a lot to grasp in the first session. I would say that maybe go through this training again, or maybe reach out to us. And obviously, you should create your own lab and try these things out. Only then we will understand it well. But right now, any questions about this, about the flows, whatever we discussed?
So one question, can you go to T3 slide? In that show IP emerald, like VRF emerald, we don't see any OIL.
Yeah,
Yeah,
So incoming interface is VLAN 30. Like there is no outgoing interface.
yeah,
So is it expected or any reason? Yeah.
that is always expected. I can't think of a specific reason. It's just that, uh, we never see the oil here, but it's always encapsulated.
Okay.
But yeah, we don't see oil here, and that's the case. You will always see on the sender VTEP
Hmm.
when you're using OISM.
Okay.
Yeah, I mean, it sounds like it is not routing it. I mean, if you see the inner TTL, it only decrements when it gets routed on VTEP 1. But then if it is not getting routed on VTEP 5, then it should work without this mroute in VRF blue, right? Technically.
Yeah.
But then it does not work. I mean, if you, like if somehow this mroute is not present in VRF blue, the traffic will not even get encapsulated. So
yes.
it's a bit, yeah, a bit weird, but we don't have a while, and still traffic will get encapsulated.
Maybe one
Hmm.
reason of that is that we are just bridging on the source VTEP.
Yeah,
If
but
we
Hmm.
if it is bridging, right, then we don't need a M route here, ideally.
Yeah.
yeah,
That's what I'm
Through
trying.
snooping itself. Yeah.
Yeah, just with snooping where you have the PIM tunnel, that should have
Yeah.
worked. But I guess it is needed to encapsulate. I'm not saying it is routing it, but this M route is needed to encapsulate the traffic. Yeah, but I can understand it can be confusing why there is no while.
Yeah.
maybe it would have been a more intuitive. Let's say if at all OIL was 4094 or something like that.
Yeah, exactly. Yeah.
But that becomes
Yeah.
routing, right? I think it's just
Or
a
kind of loopback one or
Or the underlay interface, something.
yeah. And yeah.
But again, because of their implementation, right? So because they're just bridging it, and that is why we don't see OIL. Like let's say even a normal setup, right? Let's say if there is any interested receiver only in VLAN 30, and if you're receiving the feed on VTEP 5, and we just have an SVI, we will just see something like this only, right?
Yeah, we will create an M route, especially
But
when
if there is a receiver under the VTEP 5 itself,
No, let's say
we won't see OIL.
there is one receiver in VLAN 30 only on VTEP 5.
Hmm.
We will still create an MROUT like this because we have an SVI.
Okay.
so basically it's just the regular PIM behavior where you have an SVI with PIM enabled. I think it's IP IGMP in this case. And you receive traffic in that VLAN. We'll create some M route like this.
Yeah, but Sudham, so if there is a receiver present on VTEP 5 and if the receiver
Fine.
sends IGMP report, then the M route will be created with the OIL.
No, if it is in VLAN 30 is what he's telling. That time it will still look like this only. No?
Okay, yeah, correct. Then it is bridging only, right? It is just
Yeah.
source
Yeah.
and receiver in the same VLAN. That is bridging.
Yeah. So I think they use a similar logic here because they're bridging because they're using the same BNA 30
Mm.
over VXLAN.
Yeah, but still, I think people will
Will confuse. Yeah, I understand.
because you
Very
have M route. If it is again, if it is bridging, right? Why do you need this M route at all?
Right. Yeah.
And, but yeah, it without without the while traffic is still encapsulated. That's the key thing we need to keep in mind.
Yes.
Good.
Any doubts, guys? I think that's all we had for this session.
Yeah.
Okay, then
So
I'll
much.
stop the recording.